As we look at example 11, again, this is a work problem. Here someone can get the job done in 2 hours. This person gets the job done in 8 hours. How long will it take working together? And there you would multiply each term by 8t. And I think you can do that. For number 12 is a little different. It says, one housekeeper can clean the room twice as fast as the other. And together, if they're working, they get it done in 8 minutes. So here you already know the time they're working together. So what is the rate of one housekeeper? T. What's the rate of the other? Twice as fast. 2t. So again, you set it up as a work problem, and now we want to solve. So our common denominator here will be, think of it for a moment, 8t. So we do some canceling. Here the t cancels out. Here the t and a 2, and this is left with a 4. And then here the 8 cancels out. So we now have 8 plus 4 equals t. So t equals 12. And what do you think 2t equals? (24). So the fast housekeeper can get it done in 12 minutes. The one that takes twice as long is 24 minutes. And again, together they get it done in 8 minutes. Okay, going on to something else. This is example 13. And let me give you the scenario. A fella's in a boat, and he goes upstream against the current for 22 miles. And then when he's upstream, he goes downstream with the current for 42 miles. But he does that in the same time. So we're asked to figure, and by the way, the speed of the current that he's in is 5 miles per hour. We're asked to figure out what is the rate of the boat. So again, you can read this. These are available. And I'm kind of summarizing it here. So as I said, you had to read it, make a little picture, and then think of what strategy you might use to get an answer. Well, for these, where we have distance and time and rate, we use what is called the distance formula. Distance equals rate times time. Now, what do we know about this? Well, we have some distances, and we don't know the rate, but we know the time is equal. So what I'm going to do is solve this equation for t by dividing both sides by r. I now have that time equals distance divided by rate. And we know that both our times are the same. So distance divided by rate is equal to distance divided by rate. So what do we have? Well, we know the distance of one is 42, and the rate, we don't know the rate, but we know we have the current adding to the rate, and the speed of the current is 5 miles per hour. So for this distance, we're having distance divided by rate equals distance divided by rate, and that's going to equal our other distance of 22 miles. And the rate is the same, but now you're going against the current as you go upstream. The current's going, it's pushing you, slowing you down. So there's your equation. Again, a picture, analyzing what you have, keeping in mind the speed of the current. Times are equal. In a sense, this is time equals time. And time, we said, was distance divided by rate. So you're going to go more distance because your rate is faster. Less distance, your rate is slower. And then how do we solve this? Well, we've done these already. You're going to cross multiply. So when we cross multiply, we get 42 times r, 42r, 42 times a negative 5, a negative 210, equals 5 times 22, I should say r times 22, 22r. 5 times 22 is a positive 110. So I'm going to subtract 22r from both sides. I get 20r. I'm going to add 210 to both sides. I get 320. I'm now going to divide both sides by 20. I get r equals 16. So our answer statement, what is the speed of the boat in still water? It would be 16 miles per hour. That would be your answer statement for number 13. All right, in these next few, again, we've talked about how to solve these equations already. So I'm going to spend time on forming the equations. So for number 14, they say someone walks 2 miles at a certain rate. And that's half of the time for their workout. Then later, they walk 3 miles, 2 miles an hour faster than they did originally. So that's the equation. And you would cross multiply. And number 15 is very similar. Here a fellow 3 miles at a certain rate, and then the other time, equal amount of time, 4 miles at 1 mile an hour faster. What's the rate? You want to solve for r. Now in number 16, they're driving on a mountain road and a level road. Well, on the mountain road, they do 20 miles at a certain rate. And the same amount of time, they do 36 miles on level road but here the rate is 28 miles an hour faster. So all of these equations are based on that time equals time, and that time is distance divided by rate. So if you keep that in your mind, that will bring you success. And I'm going to do another one which is a little different kind here in just a moment. Now in numbers 17 and 18, they're dealing with what they call similar figures, where here's a triangle, this is a triangle. Now I just made a triangle not proportional. The pictures aren't good, because I'm saying this side is 10 and this side is 16. And they're not really set up that way. But to show you how it works, this is 10, this is 16, and this is x, this is 4. So you set it up as a ratio. 10 is to 16 as x is to 4. And then again, cross multiply, and you'll get x's some answer. Again, in a similar thing, they're giving you a word problem where a man is saying this is a sine that is 15 units that way, and then these sides are 12 and 12. And he wants to make a model of this sine that's only 1.75 units long. So the ratio, since these x's are the same, we want to find out what would the sides be. It's going to be 15 is to 12, this side is to this side, as 1.75 is to x. And you're just going to cross multiply, and you'll get an answer for x. And again, I'm not working on solving the equations here, but helping you interpret how to set them up and what they would be.